Good evening, welcome. We're really glad you're here for our May 16th talk of the Incose Chesapeake chapter. This evening we have a talk on model-based systems engineering, when and how to use it. Eric Van Brunt is our speaker. The presentation is about transitioning organizations to model-based systems engineering, presenting a unique set of challenges that, if not accounted for, can derail any new or existing project. From Eric, we will learn lessons gained from applying model-based systems engineering to systems development with a sizable engineering team. Eric will share the insights gained from using an MBSE approach from pre-inception, that is, proposal development, through system development and testing. Eric has over 25 years of experience in the successful development and integration of mission-critical systems, including 15 years of experience leading systems engineering and software development activities on large, complex programs. His areas of technical expertise include systems engineering, software engineering, systems integration, system modeling, simulation, real-time systems development, and data visualizations. And in particular, his combined experiences in many engineering disciplines have afforded him the opportunity to be directly involved in the architecture development of both US FAA and international air traffic control systems. Prior to supporting the development of air traffic control systems, Eric was involved in supporting simulation and modeling of complex mechanical systems for the US Navy. Please join me in welcoming our speaker this evening, Eric Van Brunt.
Thanks again for inviting me. I appreciate the opportunity to come and talk, and I hope that as we go through here, you feel comfortable enough engaging me in conversation, because some of this material is, there's no necessarily right and wrong, and as you'll see, the material and the topic here is pretty much a practitioner's view of when and how to employ model-based system development. And you see a slight change in the terminology there, which I'll go over. And I'll refer to more of a system development approach than just a more limited scope system engineering, but we'll cover both. And try to talk through some of the observations and lessons learned in the time to start adopting model-based system development. A lot of times with some of these large programs with large, lengthy life cycles, it's sometimes daunting to try to figure out when and where to transition to newer and better methodologies. And then when you do decide to go through and take the leap to a model-based system development approach, how does one go about doing it? And the application of the methods to a specific system or domain. And we'll talk more about that as we go through. I'm going to talk very briefly about the definition of model-based system development, model-based system engineering. So if you kind of came to see a little bit more of an overview of the methodology, unfortunately, I'm not going to be giving you that full taste. I suspect that there are many, and I can give you and have provided some references to materials later on that are a great resource for the definition of those. But more so about some of the choices you have as you go through and look at model-based system engineering and model-based system design. There are a lot of choices that can be made. And sometimes as you approach this methodology from anew, it looks kind of daunting, and it looks like there's only one way to achieve a goal with this methodology, and you start to realize there are sometimes different techniques and approaches that could be utilized, and you have to figure out which one really works for you and your organization. Given that this discussion kind of comes from a practitioner's view, I think it's fair to kind of give a little bit more background about the lens in which I look at things. So my educational background, which kind of reflects a little bit of my work experience background, I'm a little bit of a mutt when it comes to engineering. My educational undergraduate degree is from West Virginia University in mechanical engineering. There we go. And there you can kind of see actually me in the middle, participating in the what they have as the Society of Automotive Engineers sponsored projects that you might see in a lot of universities. They're Formula One, and I worked on some other automotive projects. When I worked on those projects, strangely enough, they didn't give me the mechanical engineering projects. They had me working on the computer electrical engineering project, and for the car on the right, which was an alternative fuels project with General Motors, they had me changing the car's computer, so to burn methanol, M85 fuel. I got out and worked for a while, which we're going to talk about a little bit, and then I went back and got a degree at Rensselaer, a Master's of Engineering in Computer and Systems Engineering, because honestly, I wasn't really doing much in mechanical engineering as a traditional domain. I had gotten some practical experience doing a lot of software development, systems development, and when I took a new job in the upstate New York area, I realized this was a great opportunity since they were willing to pay for my continuing education to go back and get another degree in what I was really studying. So I got a master's at Rensselaer in Troy, New York. From a work experience, I confided to several people as I rolled in here at 6:30 how much I missed Route 29 traffic. I started my career right down the road, really, in Silver Spring at Link Simulation down there. I participated in the development of Navy training simulation platforms, mostly for the nuclear Navy, and that included the Trident propulsion plants. There were some other propulsion plants. I transitioned to work on the Trident command and control trainers, and I also worked on the Aegis destroyer team anti-submarine warfare-based trainers as well. Through my variety of different work experiences, you'll see that I have dabbled in almost, seems like any number of engineering fields. Mostly systems engineering, software engineering, my mechanical engineering background, which I do use from time to time, mostly in the thermodynamic, sometimes hydrodynamic aspect, electrical engineering, and with the Navy projects, some nuclear engineering as well. I left Link Simulation down the road and went to Knowles Atomic Power Lab. It's a Department of Energy laboratory that does work with the nuclear Navy. I started there with General Electric. It transitioned to Lockheed Martin, continued the development of the Navy propulsion activity, and also participated in some advanced thermohydraulic modeling and visualization. Picture on the left is actually one of the training facilities for the Navy and is part of the Knowles Atomic Power Lab. From there, while I was there, I got my degree and then moved on to and transferred back to this DC area and started work with a different Lockheed Martin group supporting the modernization of air traffic control systems. And for the better part of over 20 years, have spent most of my career through the development of several air traffic control systems. The latest have been modernizations of the en-route air traffic control system. So for folks who are not really familiar with air traffic control, air traffic is kind of broken up into several different regions, different areas of responsibility. En-route is the above 20,000 feet away from the airports and the terminal area controls, so about 20, 30 miles out per se, and covers most of the continental United States for the FAA at least. And then recently I've been working on a new project to modernize the air traffic control systems in the tower. So you may have heard several years ago as they considered privatization for the FAA, they kept throwing around that they have paper strips in the tower. Well, yes, they do have paper strips in the tower And we're working to get rid of paper strips and improve the throughput of the busiest airports in the country. So that's my background. Next is we're going to kind of transition to a little bit of introduction and a brief overview of model-based system development. I'd like to take credit for this picture. I can't take credit for this picture. It actually has come, and I believe it's actually been presented several times at other Incose type briefings, but it has become very popular and is a very good reference point for defining what model-based system development is. So model-based system development, you can see on the right-hand side, it attempts to go through and cover the entire life cycle, and also goes through and covers several different views and representations through different parts of the development activity. So it's not just system engineering, as you'll see. It formalizes the practice through the system development through the use of models. Pretty self-explanatory. Broad in scope. So the model-based system development can go through and include modeling of domains across not only the life cycles, but from system of systems to component level modeling. And then some of the benefits that you hope to achieve, the promise that you're looking for is an improvement in quality and productivity, and with a benefit of hopefully lowering the overall risk to development. It provides some rigor and precision, communications among the development team and customer, and management of complexity. So I typically look at the rationale, which we're going to get into, about why some of the changes and the inflection points that caused our organization to go through and do model-based system development. It really was centered largely on the communication coordination, not just within system engineering, but also vertically across the different disciplines as it transitioned from system engineering to software engineering. So I tend to look at, and there, as you can see, a little bit more of the sometimes restricted domain of model-based system engineering. I tend to love this cartoon by Gary Larson about the king and the moat contractor, but it's a timely definition of sometimes how words alone don't do justice. Having the model-based representation adds a little bit more insight into what those definitions and understandings of behavior that are expected between a customer and a contractor, and then within a contractor, the individual teams and the individual disciplines that are there. Pre-model-based system development, we did see, lack of connections between teams and tools. And we did see miscommunication among the parties. Inconsistent data or duplication of data. Sometimes we would have things that you'd look at and you realize that through a fair bit of the early development process, you had something that was actually represented twice, but with two distinct names that everyone was convinced were two separate things. Inefficient use of available data, and then the baseline changes were kind of slow and costly to perform. Very document-centric world where you're working on the development of documents, and it's a challenge to go through and keep documents consistent. So through some of the techniques and the use of models, you mitigate a lot of these issues through the life cycle, enforcing data consistency and promoting communication among all the parties. So that's kind of the quick sales pitch for model-based system engineering, system development, if the terminology is a little new. Some of the additional motivation that people don't normally easily attribute. we found that we had a better retention and transfer of system and software design knowledge. The more we got into model-based, away from the document-centric based, it was a lot easier to consolidate and collate all of the knowledge that we had in the system design. The opportunity for improving quality and preventing defects. And then the last one was the competitive pressure in the customer environment. In the government contracting world, there isn't many government contractors out there today that aren't doing model-based. And if they're not, they're quickly looking at doing that. The customer bases, I'd like to say, are equally forceful. They're starting to come around to that. I don't know too much. It's been a while since I've been with the DoD side of the house, but certainly with the FAA and that agency, they're starting to adopt it more and more, but they still are largely a document-centric customer, still requiring a lot of the many contract specified documents. So we really wanted to kind of look at, and we see, the picture at the bottom kind of tells, well, at least my view of the difference between model-based system development and the predecessor. It wasn't that you didn't have a assembly line before, but it certainly wasn't as automated and perhaps efficient as it could be. That was this chart I gave to my upper level management years and years ago and said, which company do you really want to have in the future? Again, kind of the strong industry standard amongst the contractors, as I said. It extended, our interest too is it extended object-oriented methodologies. I'll talk a little bit. It wasn't like we hadn't been doing some modeling. We had been. But it wasn't comprehensive. It was limited. We had some aspects of system engineering doing some aspects of modeling. We had some parts of software doing some aspects of modeling. And they were pretty much doing that to go through and encourage an object-oriented software development process that would follow later on. And so we were really interested in the aspect of the third bullet of orienting and maintaining consistency across the views of the model between the SE software and test domains within each one of those domains, and then vertically across those domains as well when you looked at it and sliced it from a subsystem or product view. And the aspect that, we spent so much time, so much energy trying to maintain documents that we lost the forest through the trees, so to speak. And we started realizing that with the models, if we focus on the models and trying to represent things correctly and evenly, that the documents really should take care of themselves. It should not be it should be a byproduct, and it's not the end product in the means to the end. So this kind of gives a little bit of a perspective and starts to talk through a little bit of the challenges as you look at some programs. Fortunately, and I kind of struck out some of the names on the bottom, but some of these program life cycles are long. On the FAA, we can expect life cycles. They want these systems. They buy automation systems. They want them to last minimally a 20-year life cycle. And so, they're looking to go through, and they have upgrades and technology refreshes and things like that within those programs. But the initial design and replacement. The in-route system that we replaced essentially at the end of 2015, we started 2008 in a deployment across the country. I was actually the deputy chief engineer on the deployment of the in-route system called ERAM. Previous replacement was built around 1968, and through a variety of different computer technology upgrades, they're able to keep the basic function going. They did some add-ons and enhancements to it, but essentially had reached the end of its plausible life. So going through and trying to figure out your opportunities on some of those things, as we'll talk through, it's not easy to go through and inject a model-based approach into a program that may have been living for quite some time. So we had really some three major programs that had occurred from about the time I joined the group. System engineering-wise, when I first showed up in the mid-90s with our FAA transportation group, we were doing a lot of structured analysis from a system engineering perspective. We stayed that way essentially till about 2000. We transitioned to object-oriented analysis, very UML-based. We did so, I think the system engineers largely in our group did so reluctantly. We did that to kind of align ourselves with where software had going. And as you see on the next line, our software group had kind of gotten out of more structured design into more object-oriented design. And although I kind of break that line there in the mid-90s, there's pieces of it that did go further back in time. But we really started to get a little bit more in earnest, and we're fully object kind of based today. But so that misalignment of the different methodologies caused issue and confusion. There was a lot of times where there were disjoint representations. And we would look at things and say, we could look at it from the view of a system engineering model and realize the software design model wasn't quite, it was accurate in intent, but it wasn't necessarily completely accurate in breadth and capability. In some cases, there was additional capability that was in the design that we didn't see initially in the engineering model. So that became challenging when you get pleasantly surprised that, hey, this is it's doing a little bit more than what we actually required it to do. But I didn't necessarily, as a system engineering or a system architect, I may have lost that visibility. So the other thing is that the methodologies that were heavily used during the concept and the system development, and then they essentially degraded over time, and really kind of once the documents were created, we were definitely in just to requirement document management. They weren't really using the tool sets to their fullest capability. They were really, once the tools had created the documents, they were done. They were largely done. We just had requirements management, and that was the basis of our development. So when is a good time to adopt? Obviously earlier the better. And in several cases, as new programs come along, new opportunities come along, those are great places to consider kind of switching gears and employing a new methodology. It's great when you have kind of that clean sheet, because trying to go through and represent things that had already previously been developed can be a little bit frustrating. It's not that it can't be done, and I'll talk to that, but it certainly is a little easier when you start with a clean sheet. So the best times during the system concept, when the system architecture is in its infancy, and modeling can really help in that stage to help drive the taxonomy that you start to develop and try to go through and organize the system components that you're trying to put together in an architecture and drive consistency. In the term of system concept, if you're working in requirements development as an agency within the government, I've seen cases where they're starting to do that. Unfortunately, they don't transfer a lot of those models as part of a proposal activity. And from a contractor view, as you receive those proposals, a lot of times it's still requirements-based, and we're going through and building models to represent that. So when we go through and do that, we found a tremendous benefit. Doing so in a proposal phase has its own challenges, and I'll talk a little bit about that. but it is extremely important. So the proposal aspect, when you look at doing this in a proposal, it's a very time-boxed activity. You start to realize how economical you're going to be in deploying and employing model-based system engineering concepts. But we have seen tremendous benefit in trying to ensure we get away from PowerPoint engineering that occurs during that time phase. Without a lot of discipline, there's a tendency for engineers to kind of quickly grab the PowerPoint kind of whiteboard and start to sketch things out and put blocks on paper. And you realize that after 3 or 4 iterations that quickly, didn't that block name, wasn't it a different block name last week? Why is it a different block name? Well, that's not the one I have. What version of PowerPoint did you have? And all of a sudden, it's a mess. So we had quickly gotten into encouraging during our proposal development to do some level of modeling to capture the system requirements and capture the proposed technical solution so that there wasn't any miscues and everyone was on the same page. So we used it as an enforcement. And when we did get to situations where we realized we were going down the wrong road, the ability within the models to adjust and refactor was a lot faster to change and drive consistency among the technical solution than if we had not done it and we did it with just documents. And then, with the earlier time frames, the ability to evolve and decompose through the development and complete system life cycle. We tend to follow a concept of trying to get a minimal amount of modeling that is absolutely needed and start to add layers over time and add additional relationships to enhance the view of what they represent. Is it ever too late? I don't think I'd like to say that it's ever too late. We have looked at some of these programs that have been 10 years into a life cycle. They have gone through the development, they're in deployment, they're in a system maintenance phase. And we have realized that if we had done model-based system development at the beginning of those programs, which really wasn't around at that time, we would have saved a lot of grief and effort in some of the problems that we had uncovered. There is techniques to go through and do this. And there is proposed ways to go through and transition. And we've started to do that on one of our projects that has been around 10 to 12 years. But we try to figure out ways to isolate and minimize how we do that. So they can be realized at any stage, but you do need to look at offset the benefits by the refactoring effort. That remodeling doesn't come for free. There is some offerings of tools out there that will reverse engineer and create a model. They look promising. I have never seen one really come to light that's been fully promising and create one that's really sustainable. A lot of times the models that sometimes the reverse engineered tools create are somewhat convoluted and difficult. They don't look maintainable for the long term. So we'll talk about some strategies in a bit about how we can do that. Some other factors, it's really important to talk about some other factors relative to timing. Just because you're at the beginning of a life cycle of a program or a new program doesn't mean you just jump in. The organizational preparedness is kind of a key element here to go through and ensure that you have staff that are already getting up to speed and understanding the modeling approach and have that familiarity. Investing in education, doing some small scale trials or prototyping to gain organizational knowledge and familiarity. Fortunately, with the Lockheed Martin heritage and even the Leidos heritage, we had plenty of other practitioners that we could go reach out to from our own group. There was a rich experience of folks that we could utilize. And not only just in knowledge, but also too in guidance. So, and we'll talk a little bit about application guidance here in 2 bullets. The availability of modeling tools and model configuration management tools. Projects I'm on right now, the project is actually called TFDM, Terminal Flight Data Manager. We have probably about over 50 people within the modeling tools, I would say, stretched across 5 teams. One team is not even in our company. It's a subcontract company at another location, geographically distributed to essentially New York and Eagan, Minnesota, and the Gaithersburg area, and a bunch of people who work from home, as the kind of standard workforce is getting to. So trying to go through and create tools that, and gain access to tools that are easy to invoke, and also to ensuring that when you have a large team, that you have some really good configuration management to control those models. If you've got a very small team of development, 8 or less, 10 or less, even then might be a little bit of a challenge. You might be able to get away without having much configuration management, but when you have multiple teams doing multiple activities, having some ability to go through and manage the models so they don't get out of hand is important. So we had a set of tools that our company had recommended. We had gone through and trialed those tools. We've also done a number of different tool studies to determine whether there are other alternatives out there, and but we had got that all lined up. Before we had committed to really employing that on a new program, we had to make sure that these tools were ready to roll. And then having readily available and disseminated application guidance. What I mean by application guidance is that how you internalize the model-based SysML type terms and usage within your organization. And you'll see a comment later on. There are lots of colors of crayons in the crayon box with SysML. And there's a natural tendency to try to figure out how to use every color. And you need to figure out which colors are really important to you and your domain and your organization, how you're going to use it, what is the minimum that you absolutely need from folks, and encourage them how you want to apply it within your organization. Without that, that becomes a mess. You have practitioners that are going in and doing modeling, and you realize that they're representing, you get 2 different people representing the world in 2 different ways. So this goes through and ensures that as we put the models together from individuals, they're actually going to have a good chance of fitting together. The tools are going to help encourage that, but you certainly, just because you have the tool doesn't mean that it's actually going to fit. And then some of the system development process modifications. When you go from a document-centric process to more of a model-based process, you got to go back and reflect back on all your internal organization processes and determine how they should be modified. Just as a simple example, you get into in a previous world, it's requirements reviews and document reviews. Well, now it's really, you still may have the requirements reviews, but now you got to look at the models and the model reviews, and you're going to go through and look at those in more detail. So those are some of the more straightforward factors. The other factor, which we've talked about, the length of system life cycle and the current stage of the life cycle. If you've got a really, really long life cycle, you might make choices that are different than if you have a very short life cycle. How you go through and represent items. If you really are going to be in a couple-year development, it's mostly COTS oriented, and you're really just providing a system integration functionality, and you might make a lot more simpler choices in representing the world of that system than if you were to go through and say, I have this system for 25 years, and I'm going to have to maintain it, and I have a large number of people who may be coming in and out of that program. The size and complexity, the larger the size, the higher complexity, that obviously drives more of that organizational preparedness. Again, I won't emphasize enough, pay particular attention to tools and configuration management. They are all different. They serve different needs in different organizations. So what works for one person may not work for another person. Increased importance on good guidance communication. So once you have that guidance, once you have the SysML knowledge, going through and making sure everyone is up to speed on it. And then also too, increased logistical coordination when combined with Agile methods. If you combine Agile system engineering, model-based system engineering, which we have done as well, on top of a larger group, it gets to add another layer of complexity. So it's just make sure you're prepared before you dive in. And again, I can't emphasize enough the kind of common sense, trial it, do a small study, get used to it, try to figure out what works for you. This is it's not for everybody, and it's not necessarily needed by everybody. But there's a lot of problem domains you can address with model-based system development. How does one get started in it? So the team's transition to model-based system development, they can be overwhelmed with the possibilities of what can be modeled. So once you kind of got into the mindset of, hey, we're going down there, now how do we employ that? The breadth of SysML capabilities and the flexibility within the models to represent things can be daunting. I remember sitting down with several engineers and sitting and talking with very respected folks within Lockheed Martin that are very respected within the SysML domain. And it was, we asked a simple, straightforward question of, well, what should we do? And it was, well, here's what you can do. We were trying to figure out, well, that wasn't a very straightforward answer. And now I realize in retrospect what their answer really was is trying not to go through and tell us what the answer was, that we had to kind of figure that answer out. Trying to figure out what is the minimum representation that's needed to provide the sufficient value in terms of effort to communicate the system design, not just to your external customers, but internally within the team. And I encourage more on the start small and grow kind of concept than to go through and just use all those features. When engineers go in and they start to see some of the model features, they have one of two reactions. It is they tend to run the other direction because it's a little daunting and maybe foreign to them because they don't have the background and maybe an object-oriented domain. Or the other one is, this is really cool. I can do everything in this. And all of a sudden you realize you're trying to figure out how to stop them from going way, 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 way down into the weeds. So, trying to go through and keep that even keel. Whatever's decided needs to be documented in terms of the application guidance to the team. You got to have that documented right up front before everyone starts digging in. You can't start into the work and then realize later, I better have some guidance to ensure everyone is more uniform in their practice. And I tend to subscribe to the following concepts when it comes to developing the guidance. I had other groups come up to me and are like, well, should I be doing it this way or should I be doing it that way? And I'm like, well, if it's right for you, then it's right. I tend to look at the aspect that if it makes sense to the entire team and it seems right and you've thoughtfully looked at that, then go with it. It's only through the lens of experience applying that domain are you going to realize whether it was incorrect. And in a lot of these cases, some of these choices are not detrimental. You can go back and readjust it. You can go through and change it. So if there's a question, of course, seek out others that have experience. But as you go through, you realize that sometimes you may not get that straightforward answer. Start small and enhance the guidance. Apply it and suit your needs. Don't get overly ambitious. There is lots of cool features in SysML, and you realize that I could do this, and I could do this, and I could do this, and you realize that I don't have enough time in the day to use all these features, and you have to make choices about what is the value that we get out of using those features within the system models. This is a kind of a representation of the SysML diagram taxonomy. This shows kind of the breadth. I think this is fairly accurate, and there may have been some additional changes as SysML is going through various revisions. We will tend to use many of these in our projects. And again, kind of that advice of just because you have them doesn't mean you need to use them. Don't get overly creative in trying to figure that out. I've looked at this and explained and many times about the different diagrams and their usage with my teams. And there's always a case of, well, do I have to create a state machine diagram? Well, do you have states in your part of the system? If you don't, then don't try to use it. And don't try to force fit to try to figure out how to use all these different types of things. We do lean heavily on the items in black. We start out, and you're going to see we will use a lot of block definition diagrams, a lot of the internal block diagrams that explain the relationship between the blocks, interconnections of the blocks. And then activity diagrams are heavily utilized, as well as use case diagrams. And we kind of put them all together, but there isn't one here we haven't used, but we'll make those choices and give guidance as to when and where should you think about using this diagram. Cases in point are like use case diagrams. You can get away with describing a lot of behavior in a use case diagram. At some point, the textual nature of the use case and use case diagram may not be sufficient enough. So to go through it, you need to add perhaps an activity diagram or a sequence diagram to help explain that behavior. So we tend to go through with, if you can get away with a use case textual representation and its relationship, we'll try to do that. Oops. Possible strategies for adoption in existing programs. I hinted to this earlier. Trial usage to gain additional adoption insights. If you've got a fairly decent size program, i.e. a system, pick a subsystem. Pick an enhancement to a subsystem. And go through and pilot that activity that can fit in a 2-month time frame with 1 to 2 engineers. Make sure they're trained or use engineers from a previous experience. Modeling an existing subsystem that has some form of documentation and embedded knowledge. And it wasn't, when we looked at these types of things and looked at trials, it was like I had really, really fairly decent documentation. But the person who had taken over that area and maintained it was 3 or 4 months new to that subsystem, hadn't fully embraced and transferred the knowledge from the previous lead in that area. And we realized that the documentation was only going to get us so far, that there was knowledge that we needed to embed from the user. So having a really good subject matter expert that was already in that area and having the documentation ready that we could go through and reflect it. And then try to figure out how we could refine that adoption or abandon it. is there areas that we can go through and start to piecemeal transition over to a model-based world? Maybe perhaps keep a high-level placeholder part of a model, and then over time we can just keep trying to whittle it away and do that. Implement a new enhancement work for something that maybe is a really true extension, kind of I hate to say bolt-on, but maybe a bolt-on element to a system. Might be a great place where it's really loosely coupled. You can really isolate it. That would be a really good opportunity. And then continue to remodel the system design through future system modifications. So those were some of our approaches that we looked at. And we actually have been doing some of these activities. When you look at, and many of these things are reflected in a lot of literature, kind of taking the approach of how you go through, there seems to be a general roadmap, but no one ever really comes out and says it. We tend to find a general pattern or roadmap that when we go through a system development, defining the system structure up early in the concept phase of trying to determine what the different system blocks are, the interaction of those system blocks, defining the behaviors, identifying the various actors on the system, defining the subsystem and system use cases, and then going through and trying to and making sure at that level you have at least a system requirement kind of traceability to those level of blocks. Do I have the breadth, the initial sketch of the system complete? And try to look at that picture before we start to go further. And then we're going to go through and refine the process and start to decompose it down into some of the software structure and the hardware structures and definitions that are there. And then make sure everything is still top to bottom decomposed and then kind of still fits back together as we look at it from the bottom up. The next one is some additional considerations. As I alluded to earlier, we did employ some Agile methodologies. Wasn't my choice. Through a necessity of time, we decided we would give it a try. It did introduce some interesting wrinkles. I'm not so sure I want to experience a lot of those wrinkles over and over again, but it was successful, but I did have some things that were side effects from it that I didn't really want to have again. The need for, when you go through and look at an Agile method, and when an Agile method, you're going to go through quick sprints, and you may essentially, instead of kind of going really wide and then kind of going deep all in a uniform process, you may choose an area and you go through and go in that area deep, all the way down to the system design, where another area is still really roughly not decomposed completely. So the need to go through and make sure your components are well established, agreed upon before engaging in sprint activity. If you don't have them, their teams are going to be a mess. They're going to be trying, you realize that there might be coupling there, making sure they're loosely coupled subsystems. As service-oriented as possible is great, because then you know that they have a chance, as the different teams are working on different stuff, that one team isn't creating a dependency on another team. Establishing a design modeling tasks per the lower level components for measuring progress. We had kind of a rote set of tasks, kind of alluded to a little bit on the previous page. You're going to do this, 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 all these different things. And there may be some areas where they're NA for that particular item, but it had to have some uniformity in the design decomposition process. It also became the burn down that we used for our sprint methodology. So we would have a set of tasks, they had a certain value, certain number of hours that we'd estimate that were required per each one of those tasks, and then would burn down so that we could measure that. Awareness that you're going to have some potential rework when They were really tightly coupled components, and teams were in different sprints. One team would go down deep. The other team would go down deep. We'd look back and go, they're not fitting together completely because they didn't have an opportunity to work that concurrently. It should be unlikely and was largely avoided. It does take careful planning and awareness of those interdependencies. If we got them on the same sprint, everything was good. If they were on different sprints, we had some issues. So getting towards the end here, just for a quick reference, some of my favorite texts I can't leave without my recommended reading list. The Friedenthal Practical Guide to SysML. It's if you're doing model-based, it's the book you have right there on the desk. The other one I've come to like a lot is the Agile Systems Engineering by Bruce Powell Douglas. And that was a really good text, especially informative as we kind of embarked on some Agile methods. If you're not even doing Agile system engineering, it's a really good text as well. And that's my conclusion.
Thank you. Let's thank our speaker. And will you take a few questions?
I absolutely would love to take questions.
So we're being taped. If you have a question, I'll bring you the microphone. Okay.
Yeah, I gather first, Leidos used to be SAIC with same area as Booz Allen and Tyson Corner. We used to go to Washington and Incose meetings down there. But anyway, getting back, have you, from concept to retirement, have you made a plan to keep records of projected cost estimates for each step? And I guess a lot of, on some programs, there's a lot of cost in doing the parametrics, gathering data and doing the studies.
Yep.
Through requirements into IV&V and deployment, and logistics later on.
Yep. So for our group, which has been a legacy Lockheed Leidos group, we were part of the IS&GS divestiture to Leidos. And formerly from there, most of my coworkers were all IBM. Very process-oriented folks. We, as an organization, had been CMMI level 5. So from all the different methodologies that I've talked to, regardless of whichever one we've used, we've been very diligent about keeping objective evidence about the quality that we've done on the different phases, and also to the productivity that we've done on those phases. So we have noticed with model-based, we can see some definite productivity improvements. More so, I think, the intangibles of how much knowledge we're actually keeping and retaining in the system, and being able to go through. The one thing I never really said was, we've had people, and one of the motivations for giving this is that we've had systems that were fully developed, fully documented, requirements, the full 9 yards, and we have key personnel that will leave, and then new ones come in, and we realize that there really was a drop in knowledge. There was knowledge that they had that we lost, that went out the door, that wasn't captured anywhere. And we felt that models were a better way of helping retain that knowledge. And being able to go through, when the new person came in to take over, to be the new subject matter expert, it was very difficult. It was very complex algorithmic area in our system. And it took them a while to really understand what was happening there. If you read their requirements, you could quickly get lost and lose the forest through the trees in terms of what the system was really behaving. It wasn't quite absolutely clear, and the models really helped that. Any other questions?
Since SysML is actually a modeling language, it's not a process or a methodology, I'm assuming your company had some kind of a methodology that you defined. You had that diagram where you're picking the pieces of SysML. And the other question would be is, what about UPDM? Is that an approach that you guys used?
We've looked at UPDM. I think that's something that we might consider in the future. And it's like in the past, once we start going on a life cycle of a program, we're probably unlikely to try to change methodologies unless we see some really, really extreme benefit to do that transition, because some of the transition involved. We watch them. We have communities of practice within the larger Leidos organization and share knowledge and experience with each other. As relative to SysML, we will step up if we see new features that we think we can take advantage of. But if we don't really see any of those features, we'd probably be less inclined to step up. But we do watch and we do keep abreast of them. So we just make that kind of judgment call. But yes.
Well, then the question is, does your organization have a profile of how you apply SysML in a program?
Not per se. We have kind of each business area has kind of evolved those out of necessity. We did have, and through our legacy Lockheed group and even some of the legacy True Leidos component of our organization, they have developed more of those profiles. But and we've researched those and tried to determine which ones might be applicable. So we did have a rich set of documentation to kind of lean from, but we don't really have at this point that defined a profile set that we can go through and employ. We're kind of getting to that point within each business domain, what we find very desirable that we want to keep maintaining going forward in that regard.
Thank you.
Yes.
Okay, you mentioned you had some organizations besides yours participating in the model, so I'm wondering, how do you host the model so that multiple organizations can get to
Very
it
good.
through their
Yes.
firewalls?
What we ended up doing was the beauty of cloud computing. So we ended up putting our system engineering software development tools for our given project in a cloud. And it wasn't just an Amazon web cloud, and it was a Gov cloud actually. And we were able to go through and with each organization find a way to open up enough of a firewall through there and to create that as a kind of a separate shared area that we can mutually get to. That has worked out the best. And actually, we have a lot of different tools that we actually open up, things like SharePoint, Microsoft SharePoints and other things, and the Amazon web cloud with some of our tool sets. And our group tends to use a rational tool set of Rhapsody and Doors and ClearCase kind of combination to manage together. And that's just something that we had used over time, and we know that suite works together well, and we've just employed it. It has worked out great. The extra benefit was I have gone through and working with our customer, convinced them when the program gets to a certain point of the life cycle where they technically take ownership of it, and we are a subcontractor to them for maintenance, we've kind of suggested that leave it be, leave that cloud be, and we'll connect you to it. And so now we've gotten our customer connected to the cloud presence as well. And that makes it a really nice uniform place for accessing. But thank you, that's a good question.
Make it quick, we're at time. Sorry.
Yeah, this might be too but could you comment very briefly about new technology infusion and model-based system engineering? I mean, many times it's, gee whiz, if we just had a widget that did this, and how one actually disciplines themselves into bringing new technology into models-based system engineering.
And you're talking about new system engineering approach or really new technical domains? So new technical domains. I think if you understand that domain very well, and you can understand the modeling language, I think that's probably the best approach. if the one thing I didn't talk about today was an aspect of technology that you bring in that's really off the shelf. So even off the shelf, new off the shelf technology, you know, how much do you really want to treat it like a black box versus a white box? And there are cases in there where we have systems, the system I'm currently developing, where I have components that have a legacy kind of COTS behavior that we are trying to leave untouched. We have a lot of development that goes on in parallel, and we realize we're going to make certain choices about representing the stuff inside that COTS box because it's a lot of effort just to document stuff that already is working. So we go through and model what we need to interact with other components. So because you know the ability to go through and try to represent that may be kind of daunting and require a lot of research. So with new technology items, as you go through and integrate new components together, you might try that approach of trying to treat it more of a black box. And if you really realize you have to expose a lot more of what's inside that technology, then you have to kind of dig in, understand it, and try to figure out a way to represent it. But you know, there are engineering models out there for a number of things that you could look at and concepts to try to figure out whether someone has maybe already represented that you can borrow. The beauty of models is that you can go through and hopefully reuse those over time. I happen to be in a domain where we tend to have a lot of development, software development. And so from a system technology perspective, we don't have a whole lot of, unfortunately, reusable components. But if you're in more of a hardware system, hardware components, it may be even more, make even more benefit from a modeling perspective.
Thank you. Thank you very much. And thank you for all of your good questions. Thank our speaker.